This is section 11.6. Title is Segment Relationships in Circles. These are the objectives. Find the lengths of segments formed by lines that intersect circles. The second one is use the lengths of segments in circles to solve problems. Vocabulary that you're going to be responsible for: secant segment, external secant segment, and tangent segment. You're familiar with secant lines and tangent lines, so it's related to what you know. Theorem 11.6.1 says this is the chord product theorem. It says if two chords intersect in the interior of the circle, then the product of the lengths of the segments of the chords are equal. This is what they're talking about. Excuse me. If you take this length times this length, it should equal this length times this length. That's what they're highlighting here. This is theorem 1. Let's apply this. It says find the value of x and the length of each chord. So if we apply that theorem that you just saw, theorem 11.6.1, excuse me, this is what you get. EJ times GF equals GJ times, JH. So you substitute those distances, those segments. 10 times 7, this is 10, this is your 7, equals 14 times x. 14 times x. And at this point, you just go through the algebra, divide both sides by 14, you end up with x equals 5. We don't stop here, we still need to find the length of each chord. So then, if we don't need x, we know that is equal just to 10 plus 7 from the original problem, 17. And for GH, we do need to use x, and we get 19. Problem number 2. We apply the same theorem. Find the value of x and also the length of each chord. If you apply the theorem, this is what you get. DE times EC should equal this other product, EE times EB. You substitute the lengths, you end up with this equation. You can multiply, divide both sides by 8. We can work with a decimal. X is equal to 3.75. Once you have x, you have to go back and find the length of each chord. AB is easy, we don't need the x, we get 11. And for CD, we do need the x, so we're going to add 8 and 3.75. And that's how we get 11.75. Next one is we're reviewing some vocabulary. Secant segment is a segment of a secant with at least one endpoint on the circle. And an external secant segment is a secant segment that lies in the exterior of the circle with one endpoint in the circle. So let's see what this says. It says that PM, NM, KM, and JM are secant segments of circle Q. So all of these are secant segments. But there's only two external secant segments, and these are the only two, NM and JM. So understand that because we're going to be using that on the next theorems. Theorem 11.6.2, the title is secant product theorem. Let me read it for you. It says if two secants intersect in the exterior of a circle, so these are your secants, AE and CE, then, this is the conclusion, the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. Okay, what is all this saying? This is what it says. If you take this length of the secant, which is AE, and you take this length of the external secant or external segment, and you take the product of them, it should equal the length of the secant times the length of the external secant or external segment. And that's what this is saying. Okay? Let's go ahead and apply this theorem. Excuse me. So once you apply the theorem, this is what you get. Notice that the distance from D to E is the secant, which is 16. And then the external segment or external secant is 7. And then let's go to this secant. Now what is the distance of this secant GE? Well, the entire distance is 8 plus x, or x plus 8. I have 8 plus x here. And that should equal, times the external secant or external segment. And this is the equation that you end up with. If you multiply the right hand side after you distribute, this is what you get. Take away 64 from both sides, divide both sides by 8, and that's how you end up with 6. From here, you need to find the length of each secant. For ED, we don't need x. We can just add 9 and 7. And then for EG, we do need x, and that's how we end up with 14. Problem number 4, we're going to apply that same theorem, 1162. Excuse me. And once we apply the theorem, this is what you're going to be working with. This is the length of the secant, LG, which is 30 plus 9, times the external, which is 9. And then you go to the other secant. You should be able to see why we have 13 plus z, or z plus 13. In this case, I have 13 plus z. And then the external secant, which is 13. From here, go through the algebra. Solve for z. And then you end up with 14 once you divide. Once you have your z, you have to go back and find the length of each secant. You should be able to see where we get 39. We don't need z. For JG, we do need z, and it is equal to 27. Theorem 1163. This sounds wordy, but I'll summarize it in just a second. Let me read it. It says, if a secant and a tangent intersect in the exterior of a circle, this is your secant, this is your tangent, this is where they intersect, then the product of the lengths of the secant segment and its external segment equals the length of the tangent segment squared. Again, this is the secant, this is the tangent. If you take the product of this secant, which is AC, times the external secant, which is BC, that's what we have here, it should equal the tangent squared, DC squared. This is what theorem 3 is saying. Let's apply this. Problem number 5. It says find the value of x. We're going to apply that theorem, 1163. And this is what we get when we apply that theorem. The secant ML times the external should equal the tangent squared. Once we substitute, this is where mistakes happen. ML is the sum of 15 plus 5, okay? 20. Be careful, don't multiply these. 20, and then the external is 5, and then KL is just x squared. At this point, multiply the 20 and the 5. If you take the square root of both sides, you end up with plus or minus 10. But in this case, since x represents a distance, you know that we only keep x equals positive 10. Last problem, and we're done with this section. They want you to find the value y. We apply the same theorem, 1163. This is what you get by using the theorem. Excuse me. Here's the, oops. So you have the external times the external secant times the secant is equal to the tangent squared. If you substitute, notice that the E is 7, dF is 7 plus y, and dg is 10, and then we square that. Once we distribute the left side and we square the right side, this is what you get. Take away 49 from both sides. And then at this point you want to divide both sides by 7, and you can leave this as a mixed number, 7 and 2 7s. And this is the end of this section.